Welcome to this video, which will introduce you to scripting in PyMOL. You should now already have installed a text editor, such as Visual Studio Code. If you've not done this, you should pause the video and install a text editor before you continue. You should also have watched the video on property selectors, as this information is used in this video. You'll be introduced to the basic commands needed to write a script. PyMOL scripting is very useful as you can prefabricate visualizations of macromolecules, which can be used for structural analysis. To the left, you see the PyMOL program, and to the right, you see the text editor Visual Studio Code. As you can see, there's already some code in the text editor. This can be used as a template for future scripts. We'll go through every line one at a time. A script can be divided into 5 sections: obtaining the structure, creating objects and selections, visualization, orientation, and saving a scene. It's considered good practice to start your script with the command reinit or reinitialize. This wipes the slate clean before you proceed to the subsequent code by removing any other structures you may have opened. The code can either be written directly into the command line, or you can copy and paste the code from the text editor. We'll be using the copy-paste method. In the last video, we introduced you to the fetch command and demonstrated how to rename objects using the action menu and the submenu rename object. By writing fetch followed by the PDB ID, comma, and kchannel, you ask PyMOL to name the object kchannel directly. Notice here that the object's named kchannel and no longer by its PDB ID. Like reinit, it's customary to add the command async equals 0. In most situations, this is not necessary, but it makes sure that the PyMOL program doesn't continue with subsequent code before the structure is retrieved fully. The next step in building a script is creating the objects and selections. This section depends on what you want to highlight. In this script, we want to visualize the selectivity filter for this potassium channel. Therefore, we create an object which contains only the amino acids that's part of the selectivity filter, and we call this object sFilter. Here we use the command create to create an object. The reason why we choose to create an object and not a selection is a little more complicated, so this will be explained later in the video. If you search for this protein on UniProt, you can see that the amino acids involved in the selectivity filter have the residue number 75 to 80. UniProt and other useful websites will be covered in a later video. Since we know the amino acids important for the selectivity filter, we can select these by using the property selector resi followed by 75-80. This indicates that the amino acids in the interval from 75 to 80 is selected. Now we would like to create a selection containing only the potassium ions and name this selection K. We do this by writing select K followed by name K. Since we know that the potassium ions in the selectivity filter are the only potassium ions in the session, it's enough to just select all potassium ions. In this case, the element selector would have been just as useful as the name selector. In a case where they would not have been the only potassium ions, you can just click the potassium ions one by one and note their residue numbers in the log. With the command deselect, you remove any marked selections in the session. These marks are little squares. Since the last selection we created was K, the potassium ions have these little markings. We want to remove these. Looking under sequence, we see a residue called TBA. This is tetrabutyl ammonium. TBA is used as a solvent when you're determining crystal structures of nonpolar proteins, so its presence is therefore only a product of the structure determination. Since TBA is not relevant for the structural analysis, we can use the command remove resin TBA. Notice that the molecule is both removed from the session and from the sequence. Therefore, you can no longer access it. In the last video, you were introduced to the color menu, which you could use to color an object according to chain. The command that does just that is util cbc, which stands for Utility Color by Chain. As you can see, there's 3 potassium ions included in one chain and 1 in another chain. This comes down to the way the property selectors have been defined by researchers. For atoms that are not part of a peptide chain, this designation is somewhat arbitrary. We now use the command as_sticks, sfilter. When you use the as command, you ask PyMOL to change the visualization to sticks instead of laying the representation on top of the current visualization as the show command would have done. Here, it's an advantage that we chose to define sfilter as an object instead of a selection. If sfilter had been defined as a selection, this command would have created visible holes in the main chain. Using the command color white, sfilter, we color all the atoms in the object white. But this is not an appropriate visualization if you're trying to show polar interactions. For this, we need to highlight the different elements. In the last video, you were introduced to the function color by element, which had different colors for every element. This visualization is better suited for presentation of polar interactions. The command util_cbw stands for utility color by atom, and the last letter, W, selects that the carbon residues should be white. We use the same command for the K selection. Again, it's an advantage that we defined sfilter as an object instead of a selection, because otherwise it would not have been possible for main chain and side chain to get different colors in just one command. One of the most important parts of your script is to save a point of view which shows what you want to show. We want to show the selectivity filter, so a good start is to use the function action and orient, since this is PyMOL's suggested point of view of that object. After this, we use the command getView, which prints the exact position of that point of view in the log. This you copy-paste into your script. Lastly, we'll save the scene under the name f1 with the command scene f1, store. Now you've saved the scene. You can always return to this scene by clicking the square with the name f1 in the lower left corner. When you want to create a new scene, you have to be aware of the current visualization because this is the starting point for the next scene. Scene f1 shows the entire selectivity filter. Now we want to focus our attention on the interaction of a single potassium ion. We start by hiding the visualization of the sfilter by using the command hide_sticks. Then we create a new object which we'll call K-complex that contains only the amino acids in complex with the frontmost potassium ion. These have the residue numbers 77, 78, and 201. Notice here that you use the plus sign to include more residues in your selection. We then show K-complex as sticks, color after element with the carbon color white, and hide the other potassium ions with the hide command. We then find a good point of view for the scene and use the getView command, copy-paste it into our script, and lastly we save the scene under the name f2. We can now switch between the two scenes by clicking the two squares in the lower left corner. If you've saved the scenes with the name starting with F and followed by 1 to 12, you can use the function keys on your computer to recall a particular scene by clicking the corresponding function key. In scientific articles and literature that use PyMOL, you'll often see a white background. Therefore, the last command that you will be introduced to is bgcolor or background color. You can choose any color that's registered in PyMOL, but the standard is either black or white. You should now have been introduced to all the basic functions and commands in PyMOL necessary for scripting. From now on, we would recommend that you create your own scripts when completing an assignment.